Okay, Chem, today we're going to practice taking names and turning them back into formulas. And this is a little flow chart that I've given you, and we're going to review exactly what each of these means. So here it says given the compound name. So you're not given the formula. You need to create a formula from the name. The three things you're going to ask yourself: is it an acid? That means that the word ends in acid. Is it ionic? That means that you're going to look and see, is there a metal in the first position, a non-metal in the first position, or a polyatomic ion? So in order to say it's an ionic compound, it either starts with a metal or it starts with ammonium, which is a polyatomic ion, which acts like an ion, therefore makes it an ionic compound. Or is it covalent, meaning that it starts with a non-metal? These are the easiest ones. If you have a covalent compound, you simply turn the prefixes into subscripts. So you read it and write it down. If it's an ionic compound, you need to use the ions. That's because we need to balance the charges. There has to be as many positives in front as there is negatives in back. The same thing goes for acids. You're going to use the ions also, except for the cation is always H+. Now it says here in this box that you can crisscross to determine the charges. You just have to be careful because if you can reduce an ionic compound, you have to. Acids are a little easier because the cation's always +1. So that it also tells you how many acidic protons that you need, or H+ that you need. That being said, you can look at your flowchart while we practice doing this. So let's do binary ionic first. I'm not doing this in order of easiest to hardest. I'm doing it in order of binary to ternary to acids. So when it says ion charges, I need to be looking at my periodic table of the elements. Calcium is an alkali earth metal. It has 2 valence electrons, so its charge will be +2. Sulfur has 6 valence electrons, so it's going to grab 2 more to be like neon and has a charge of -2. So we have +2 and we have -2. You recognize those will go together 1 to 1, so the formula is calcium sulfide. Silver nitride. Don't make the mistake with silver. Silver, if you remember, we put an O around it because it is only +1. You can also look in your list of single atoms or single elements, which is to the left of the polyatomic ions. It'll remind you that silver is +1. Nitrogen has 5 valence electrons. It's going to grab 3 to be like neon. Therefore, it's going to have a charge of -3. So I can think of dropping the charges down like such, 3 for silver and 1 for nitrogen. Or I can just think, how many silvers do I need to neutralize the -3 from nitrogen? So my formula becomes Ag3N. Believe it or not, this makes it easier because I know the charge of my chromium is +2 and my chloride is -1. So the formula becomes CrCl2. I'm just going to keep rolling along. Remember that we learned all about the charges on each of these ions since the beginning of the year. Aluminum has a charge of +3, so it's going to need 3 -1s, or you can drop aluminum's 3 down to fluorine, and that will be the formula. Remember, when it comes to variable charge metals, the charge is the same as the Roman numeral. Let me drop the charges down, or recognize the lowest common denominator between iron and oxygen at 2 and 3 is 6. So I would need 2 irons to have a +6 and 3 oxygens to have a -6. Lead 4, Pb 4 plus, sulfur's 2 minus. So this is where you got to be careful. If you drop it down, sulfur at 2 and iron at 4 can be reduced down. Or you can recognize that I just need PbS2. Now let's go to the covalent. These are the easy ones. So for every single time, I'm going to write does not apply. I don't need the ions. I don't care about the charges on any of them. I'm simply going to read it and write it down. I'm going to turn my prefixes into my subscripts. So remember, if it doesn't have a prefix on the first, that's mono. And then oxide has a mono also, so this is carbon monoxide. Phosphorus has no prefix, so it's 1. Disulfide. Carbon dioxide. We do not switch, so that's the only mistake I see kids trying to make, is wanting to drop the charges down. You don't do that for binary covalent compounds. Silicon, tetraiodide. Diphosphorus, this time the first one does have a prefix, it's 2, and pentaoxide is 5. Let's go to ternary and polyatomic ions. So you're going to need to go to your list of polyatomic ions to find this. Lithium is not going to be in my list of polyatomic ions, but I know the lithium is an alkali metal, so its charge is +1. I find iodate, which is IO3 -1. These are guys that are going to go together 1 to 1. Remember, you have to make sure that the charges balance out. Ammonium is our only positive polyatomic ion, and then we're going to find phosphite, which has a charge of -3. In order to have 3 pluses, I'm going to have 3 ammoniums. Remember, when I have more than one polyatomic ion, I need to have parentheses. Copper's charge, again, is given by the Roman numeral of +1, and carbonite is a -2. So I'm going to have 2 coppers, or I can think about dropping carbonite's charge down like such. Remember, compounds are always neutral. Barium is 2 plus, and perchlorate is 1 minus. So I'm going to need 2 of the 1 minuses to balance out that 2 plus. Aluminum hydroxide. Be careful on this one because I need to have 3 hydroxides. So what I'm going to see is people writing down AlOH3. That is incorrect. You need to have parentheses around the polyatomic ion. Without the parentheses, it says that we have 1 aluminum, 1 oxygen, and 3 hydrogens. With the parentheses, it says I have 1 aluminum and 3 hydroxides. Tin, 4, and cyanide. Same thing goes here. I'm going to have 4 cyanides, so I need to have parentheses. Those are probably the hardest ones, is either the ionic binary or ionic ternary. Acids can be a little bit easier because every single time for each of my acids, my cation is H+. So my anion is going to tell me how many hydrogens I need. So this one says acetic acid. Remember, it doesn't have an hydro, so IC acid means that my polyatomic ion used to be, or what I'm looking for, is acetate. It's an ATE. So I find C2H3O2 is acetate, and it has a charge of -1. This is what tells me I need one hydrogen to balance out the -1. Hydrophosphoric. If you go and look at your 3 little types of acids in the bottom right-hand corner of your polyatomic ions, you'll find out that this means that it's binary. So this is hydrogen with a phosphide. So it's going to be H3P. Hydroic acid is just looking for the chloride ion. So it's HCl. Chloric without a hydro means that it used to be chlorate. So I'm going to look for chlorate in my polyatomic ions. And I get ClO3 with a -1 charge. So HClO3 is chloric acid. Now let's look. OUS acid means that I'm looking for a ITE. So I'm looking for sulfite. And that's SO3, and it has a 2- charge. The 2- charge tells me that I need 2 hydrogens, so the formula becomes H2SO3. Come down here, I have no hydro. I have an IC acid on the end. That means that the polyatomic ion I'm looking for used to start with ATE. So when I look up dichromate, it's Cr2O7 with a 2- charge. That means that this acid will also have 2 hydrogens. So this is how we take formulas and turn them back into names. It is the same concept we've been doing all along. You just have to think backwards. But remember, you've seen each and every one of these compounds before, so it just takes practice in order for you to master it.